How's it going? Good to hear. Well, today we're going to talk about hole notes, specifically countersink and counterbore holes. And then I just got a brief exercise for you guys to draw up in dimension, including countersink and counterbore holes. And I know a lot of you still need to finish up the ones before, so you'll have the rest of the time to do that as well. So even if you're finishing those up, if you'll please push pause on those and give me a few minutes to talk about hole notes here. This is in your book on page 188 in the dimensioning section. And we're going to take a look at counterbore and countersunk holes, like I said. We've also seen spot face holes already. We can see a spot face one here, and you'll remember that with the spot face, we're given the diameter of the spot face, but not a depth, because we just wanted to cut in enough to get a nice smooth surface. So we said maybe a millimeter or a 1/16 of an inch on those. Looking at a counterbore though, the way that we call this out, a few things that I want you to take note of is, first of all, that again we use a leader that's pointing towards the center of the circle. So for that reason, I typically start with the diameter tool instead of just the leader tool, so that's pointing. You start with the diameter of the inside hole. And sometimes you'll see through written on there, and that's not necessary. We typically don't put that as part of the dimension. A lot of times you'll see it on exercises because you're given an isometric view and you can't tell if the hole goes all the way through or not, so you'll see through written on there. But just by itself, this means that the hole goes all the way through. Just like if all you had was a hole note that said that, it's assumed it goes all the way through since you're not given a depth. So that's our counterbore symbol for the larger diameter, and we're told the diameter of it, and we're told the depth of that counterbore. So it's a hole diameter, counterbore diameter, and then depth when doing a counterbore. And we'll do squared off edges, so we won't have to worry about calling out the radius on these. So here's an alternative where it's actually using the text. You'll see that occasionally as well, but we're going to use the symbols in here. That's typically the ANSI standard. And then if we take a look up on the next page on the countersink holes, this is where you've got the angled cut in so your fastener can sit inside there. And once again, you start with the diameter of the inside hole, and then you have the countersink symbol. And sometimes you'll see it in books where it looks like the letter V. We actually have a symbol for this that I'll show you. And then the diameter of the countersunk hole. And instead of giving you a depth, we do the included angle. So the included angle is from here to here. So a couple of standard angles that you'll usually see are either 82 degrees or 90 degrees. So when you do one, don't just assume it's 82. Check the angular dimension and see what that value is. And then again, we got a symbol for the degree as well. So I'll use these couple of hole examples and add them into AutoCAD so you can kind of see the process there. Let me start with the counterbore hole. So it had a diameter of 0.38 and then a counterbore diameter of 0.75. So then as I draw that into the front view, I'll use some rays here. I'm going to go from the quadrants down. And then the counterbore depth we were told was 0.25. So I'm going to track down 0.25 here, and that will be my counterbore. So now to trim out. There we go. The number one mistake I see on the counterbores is people have a tendency to leave this line out. And that's two different diameters of cylinders. So there's a flat surface that wraps all the way around. So that line needs to stay there. And of course, this one is going to be hidden. And then I can go ahead and draw my center line in there as well. So then let's take a look at the other one, which again is a diameter of 0.4 for the hole and a diameter of 0.8 for the countersink. So again, I'll Use some rays to extend these down. So this time, instead of a depth, I'm going to have to use an angle to figure out the countersink, what that looks like. So if I've got, let me draw in a little center line here real quick. Let's try to come with this. Okay, so if that's my center, and I'm talking about an 82-degree included angle, then that means that from this line over, it's going to be a 40, for example, if I had a line here, it would be 41 degrees between these two, and then same thing on the opposite side. So various different ways I can do that. I'm just going to rotate this line from this intersection. And I want it to go counterclockwise, so that's positive, so I'm just going to put in 41 and enter. Now I could do the same thing on the other side, but I'm going to save some time here and mirror it. So I'll mirror it about this center. Whoops, I should have hit under there. Let's do that again. And then connect that across. Do some trimming. And then again, these will all be hidden now. And then I'll double check myself on my angle. And there you can see the 82-degree included angle that needs to be there. So today you'll be drawing up and dimensioning, but sometimes you'll be given the views and you got to add your dimensions, obviously, so you'll need to pull some angles in. So then to finish this out then and actually call out the dimensions, I'll hop over to my B size tab. And like I said a while ago, I would not recommend using the leader tool because, I mean, you can do it and eyeball it and point it to the center as best you can. And that's fine if you want to do that. But just make sure that it's actually pointing convincingly towards the center. I typically will go ahead and use the diameter tool. It also saves me a little bit of typing as well. So I'm going to call this one out. Again, pointing to the outside one. I'm going to double click on it. I'll start with the 2 times since there's 2 of them. And then I got to start with the inside diameter. So for my symbols, you can come up top to symbol here, diameter right there, or you could type %%C. So I've got 2 times a diameter of, I guess I'm doing my countersink one first since I started with that, 0.40. And then now I want the counter bore symbol. And I'm going to come back and do my symbol last. I like to, well, it'll be okay on this one. It's the counter bore where it's kind of goofy. So I'll go ahead and put in my symbol. So I'm going to go to symbol. You're not going to see the counter bore symbol up here. You've got to go to other to bring up the symbol dialog box. And in the symbol dialog box, you need to be on the GDT font. So if it's on anything else, scroll to GDT, which stands for Geometric Dimensioning and Tolerancing, and it's something we'll be doing here in a couple of weeks. But here you can see my, oh, I'm sorry, I'm doing countersink on this one. So here's my countersink symbol. So I'll just double click it to where it shows up in this box down below, and then it's a copy and paste. So I'll hit copy and close this. Then I can come back in and Control V or right click and paste to put the symbol in. It always puts an enter after, so I'll just backspace. Now I'll arrow to the end, so I've got a countersink of 0.8, and then when we're doing something by something, we always put spaces in between. And so then I've got 82, %D for degree, or again I could use, whoops, the symbol drop down. So again, remember if you're doing a count, you don't put a space between them. If you're doing something by something, you put spaces between them. So that'd be the appropriate way to call that one out. And then if I'm doing the counter bore, then I'm going to, again, start with the diameter tool on the outside one. And then as I edit this one, again, I'll start with 2 times. And then the inside diameter, so I'm going to go %C for my diameter symbol. And then the inside one was 0.38. And then I need my symbol for the counter bore, but I'm going to hold off on that. I'm going to arrow to the end, and then I'm going to go ahead and put in my depth value of 0.25. Then I'm going to come back and put my symbols in, and I'll show you why in just a minute. So now if I go back to symbol, other, then I can go ahead and bring in my counter bore copy, and then Control V to paste, and backspace. And then now I can come back in and put in other, and here's my depth tool, copy. Again, I can close this and then Control V to paste. So I've got 2 holes with a diameter of 0.38, counter bore diameter 0.75, depth of 0.25. I'll show you why I like to do the symbols last. Here's what happens if you don't. I'll just do the last part of it. If I go in and put in my depth symbol, it changes the font size. So then when I get a 0.25, and then I've got this weird font size, and I got to go back and mess with it and adjust it. I think it's easier to just put in your values and do your symbols last. So. Alright, so I'm going to pass this out. It is a pretty simple shape with some holes in it. So I've given you the notes of what sizes the holes are, but I didn't write out the note exactly like it should be done. So again, consult page 188 and 189 as you're doing those. So 3-view drawing with all your hidden lines and center lines, and then call out the holes appropriately.